be going. Did it send y'all an invite? Anybody check for me? Let's see if I've got it broadcasting. Okay, so it should be broadcasting live so people can, so y'all can even view it later. That was my whole goal here. Okay, so what I'm going to look at first is, let's look and make sure you understand the new grading scale and what I did there. If you go over to content, down under course info, all I did was I've changed the syllabus, so I just pulled the grading scale out of the syllabus so you didn't have to go into the syllabus anytime you want to see what your grade is. So what I did was I took out the attendance points, and I incorporated them in with Khan Academy. So 10% of your grade is the 50 points for Khan Academy, and the activities on Khan Academy, so I upped this to 530 total points. It was at 500. So anybody on the chapter assignments, in chapter 1, if you just completed them, I gave you the 10 points. If you completed project 1 and maybe all you didn't do was put some of the output or something, I mean, anybody that did the pseudocode, you got 10 points, the flowchart you got 10 points for, and the JavaScript you got 10 points. So that's how and that's what your rubric said on that project, and that's how the test will be. But the chapter assignments, I'm not going to be able to grade all of those. I'm just going to check your folders and open it, see if you have it in there, and if you do, then you get the points for the chapter assignments. Khan Academy tells me whether you've completed an activity that was assigned or not, so I don't have to grade those. I just give you the points if you've done those, okay? And originally I wasn't going to give you points for Khan Academy, but I know most students won't do it unless they do get points, and I feel like it's a really good learning tool. So I wanted to be sure you do those this semester, especially since I think I have only one student that maybe has a little bit of experience with any kind of programming. So on the grades, then you should, across yours, you should see under Khan, I've graded the variables. That's the only one that you got credit for, but it was good to have done the programming video, and there was another one I had y'all do. What was the other one? I can't remember, before variables. But there's one that I didn't realize was there on pseudocode and how to go through and create your pseudocode. So that one is in our Evernote this time. But here are the ones that are in Khan Academy that I give you points for. If you want to look at your grading sheet in D2L, it should show those listed. And it just won't show grades except for the ones as you finish them. And I'm not going to have a due date on those, as far as I'll give you credit for those up to the end of the course, okay? But they are beneficial if you do them. Like right now we're getting ready in chapter 3 to do if logic, and so that particular one in Khan Academy would be very beneficial to you to do those. Then you should have the quizzes, the test, and these are called A1 assignments. They're actually the projects, which I changed the name, and I didn't change the category name up here, but they are, because I didn't want them confused with the chapter assignments, so I've called them projects now, so that in Evernote you'll know the difference. These are the program assignments. Project 1 should be under A1, because I should have graded yours. If you don't have a grade on Project 1, then I didn't find it in your Google Drive. So if you see it there and I didn't give you a grade for it, then you can email me and let me know.
You haven't graded chapter 2 assignments yet, right?
No. Okay. Just, I won't do 2 probably until we take our next test. But I did notice that some of you had chapter 2 done. But if I don't have your project, then and you did it, then that's the ones I'm up to the projects, and that's only for this class. Those of you, if there's any of you in the that watch the video, I haven't graded the other sections. I hope to get that done today. Okay, so any questions about the grading changes or any of that, what I have graded up to now? Okay, so now what I want to do then is look at our Evernote before we actually.
Chapter 3 in Google Drive, do you want Chapter 3 Part 1?
No, just put the exercises all, just Chapter 3 and then name them Part 1 and Part 2. Yeah, you don't have to have separate folders if you don't want, just so all of Chapter 3 is in Chapter 3. Okay. All right, Evernote then, if we look here at what I've added, you're Mariah, right? Did you get your book?
Yes.
Okay. Because I know I never did get to giving you the end of Chapter 2. All right, so we are down. Let's go over a little bit of Chapter 4. Not Chapter 4, I'm sorry, Week 4, so that I make sure that everybody, because we didn't get everything covered that I was going to, and I didn't get it recorded, so I want to be sure there's nothing that I need to review there, because today we're going to go ahead and start into Chapter 3, but I want to make sure in the Chapter 2 examples that you all had everything. This was a solutions doc that I added for Chapter 2. So if you have problems, I'm actually maybe try and get Chapter 2 graded this weekend too, since we're going on to Chapter 3. But I did, I believe all the solutions are on this solution doc. I believe 8 and 9 are there too. Those were not assigned. That's just if you want to read another problem and try to do it just to make sure you're understanding. Okay, that's why I post these other solutions out there for you. Okay, reading assignment was Chapter 3 here. This was week 3. Okay, so week 4, which was last week, we took the test, and that's the other thing. That's what I'm going to go over next before we start into Chapter 3. Make sure, even though I don't have those graded, you'll know what some of the answers were. Then I listed the link for that, and then there's a whole folder for Chapter 3 JavaScript examples. Here was the Chapter 3 assignment Part 1, which you were to do on page 110, which you probably haven't done yet because I haven't actually covered Chapter 3 yet. So on page 110, it was after you did the Word doc, then you had exercises 2 and 3, pseudocode or flowchart. Is that Part 1, right? Yeah. Oh, and it says up here, I didn't include that down here, include JavaScript for 2 and 3. So you did not, down here you didn't have to do pseudocode and flowchart. You could pick either or for problems 2 and 3, which are on page 110. Was number 2 was the Happy Cow Ice Cream Company. Number 3 was the Romance World Cruise Line. And so these are not due until today's the 15th. Wednesday in this class, okay? Wednesday in this class, because I'm going to cover them in class on Wednesday. So if you don't get them in there by then, I still, until I grade them, it's okay, because I don't take off points if you don't get them correct, but it's to your advantage to try to work them prior to me working them in class, right? Because then you know kind of what you know and don't know, all right? So even though I'll give the answers, you could still put them up there. Put your work up there so I can see that you've done it. Then we will finish Chapter 3 this week, and you have, oh, I don't know why that says Chapter 2, Part 2 assignments, because those were already due. Did I do that? Huh. Oh, that's today. Okay, I was going to ask you, that's what it says, Chapter 2 problems in class, because if you have any problems with Chapter 2, the problems that were assigned, after I go over Test 1, then we can go through any of those problems. It just cuts into our lecture time, but if you're reading the chapters and doing okay, what I prefer doing in class is working problems, because that's what you have trouble with. So if there's parts of the chapter, that's why I give you the PowerPoints and all, but if there's parts of it that you don't understand, then I'll cover it. But it's really more beneficial to you all, I believe, if we work problems in class, okay? So you tell me if you rather me go through the lecture part, which some of it I'll highlight anyway. All right. So there was in class put number 3 in JavaScript. Okay, that's one of the assignments, wasn't it? Up here was 2 and 3 in chapter 3, right? There was chapter 3 assignments. Yeah, there. Okay. So I was going to try. That's probably when I'll get to this part. Will be on Wednesday. The putting number 3 in JavaScript, so that gives you some time to do it. And then this we won't get to till next week, so I expect you to work on it over the weekend, okay, after Wednesday, and get part 2 of assignment 3 done. And so there's everything. There are more Khan Academy activities this week, just because I found that pseudocode one, and it's basically just a video about pseudocode in Khan Academy and how to use pseudocode in comments, which we've talked about, but it's how to document your programs and how beneficial it is. And then the text and strings is because we've been talking about variables and we have used text and strings, but this is a whole exercise on text and strings so that you're able to use them correctly in JavaScript, okay? And then this one is on what we're covering in Chapter 3, logic and if statements, okay? So that part you can do in Khan Academy, and so right now I'm up to the part where I'm going to go ahead and cover Test 1. Are there any questions? Have I kind of put too much out there? Y'all have any questions about what I said? No? Everybody okay? All right, this Monday morning is kind of tough, isn't it? Only it is 11. That's not quite as early. Anybody have an 8 a.m. class today? Oh, that's good. When I was in school, I had 7:30 a.m. classes. That's pretty tough. 4 days a week. All right, so Test 1, we're going to first look at the problem. So let me go over here. All right, let's see. Okay, so the problem was to create an application that allows a student to calculate their tuition bill. They will enter the credits they have scheduled to take for the spring semester only. The per credit hour rate will be $79 per hour. Then the fees charged per semester are $21.75. Then display the total bill for the spring 2014 semester. Okay, we didn't go through this. Must have been my Tuesday class then. Okay, so what we want to do, first of all, is we need to step through creating our pseudocode or flowchart. I always do pseudocode first just because then you can take what's in your pseudocode and just put it in the correct shapes in your flowchart, because the text doesn't change, just the flow where you can see what's input, what's processing, and what's output changes in the flowchart. Okay, we can actually look at somebody's if they want me to bring theirs up. Does anybody have one they want to do? Derek? Okay. Let's go and do yours. I don't think we've done yours on a. I'll kind of switch around. And that way we can see. Oh, I did already have that up. Okay, let's go here and here. And Google Drive. Okay, so where is ours? Is 7096 DB. Yours will be in test. Okay, so I'm going to download the zipped file, which he did that correctly. He had nothing but the zip file in his folder, which is what you will receive some points for also. If we look at the test document, it tells you here, doesn't it, what each one? Yeah, pseudocode and flowchart are worth 30 points, so 15 points each. Then the JavaScript was worth 25 points. If it doesn't work but you coded it, it's at least 7 points. Sometimes I give a little bit more. Then if you zipped and uploaded it into the test folder with this name, then you got 5 points for that, okay? So far, Derek's got his 5 points. All right, so let's look at, oops, where'd that go? Right here. I should have downloaded it into, here should be T1, is that what I called it? Yeah, T1DB, so I'm going to unzip it. When I unzip it, he did his in 3 documents. You could have had your pseudocode in your flowchart. What would you use your Lucidchart or Visio? Lucidchart, okay. You could do it either way. You could have had just one PDF and then your JavaScript, but this works too. The only thing, and I won't take off any points this time, but next time you don't want spaces in any of your names because it'll cause you problems. It'll probably cause me problems running this JavaScript here. I'll probably have to rename it. Even though it maybe didn't you, when it transfers to somebody else's drive and they try to run it, it puts % signs in there. Okay, so we're going to look, well, let's look at the pseudocode. Okay, let me see. Let me get this big enough so you guys can see it. Okay, his pseudocode, he did start input num, output equals num times $79 plus 21.75. My answer equals output, but then you didn't put your output statement, right? Okay, but you probably did in your JavaScript if it ran. Okay, so the other thing that some of you might start doing, even if you haven't at this point, maybe they do that. Doctor's office. Okay, so what else can we put in our pseudocode? Declarations for our variables. So that would be another thing that you might want to put here, and you would probably have 2 variables, and then we also talked about another kind of variable, constants. Okay, so if we wanted to, which I won't save this, but we could say / declarations, and then we could put in a var. A constant would be maybe the credit hour rate, so we'll call it credit underscore rate equals 79.00, and then we could say var, oops, I can type var, can't do it I guess, VAR, and what's another constant? Yeah, so that was like a fee, wasn't it? Fees. So let's just call it fees equal 21.75. And then we need a variable, oops, a variable called num. And what other variable do I need? Total. So total. All right, so now if that was my my actual variables names, then this would say total equals num times what? What I call the constant credit rate. Credit rate plus fees. All right, and then my output would say output, oops, not caps, out total, right? And stop. Okay? All right, so we've got, but he did do pseudocode. I won't be as picky on this first test. Pseudocode, and then he had his flowchart. Let's see how his JavaScript looks. So I'm going to oops, not there. Open this one. Open it with my Dreamweaver that's already open. Okay, let me put this in design. Oops, not design. In code mode. And let's see if I can get it up a little larger for you guys. Fonts. Let me code view. There it is. I'm going to go up to like 20 points. Apply. There we go. Close. Okay, so in his actual JavaScript, he did use constants. You might want to next time make these all caps, but you did use constants here. And let's see, you didn't go ahead and define num1 up here, but it worked. Sometimes it will and sometimes it won't, okay? So he should actually have a value for a variable declared for num1 and a variable declared for, here he called it output, okay, instead of total. So it says, here's his input prompt where he gets the one value. And some students, I think, had trouble. In my other class, they had 2 input variables. And we only need one because the problem said, how many credit hours did you take, right? Anybody? So there's one input. And then this, if it matched his pseudocode, we'd change this to the word total. Oh. Thank you. Maybe do it one more time, probably. Maybe not. Okay, so here we have num1 times our constant credit hour plus the fee. Then he has document.writeLine. He wrote what it told you to write in as the output label with a $, and then he did a document.writeLine with output. You can also do this in all one document.writeLine, but if you didn't know how to do that, this works fine too. All right, so let's see if it runs. We'll do preview in Google. It may make me change the name. Nope, there goes 2. No, what did we try it with? 12. Yeah, there we go. 12. I was thinking of the problem. Your tuition for spring 2014 semester is $969.75. Okay, so that was the correct output according to what I told you all in here when you did a run. Your test run should be 12, and there was what your output should look like, and his looked like that. So he got the correct answer on the JavaScript. If you got that answer, but your code's just a little bit different, that's fine. This first one, I'm interested in you getting that output, okay? All right, so any questions about test 1? Okay, so I'll go back and I should be able, now you know pretty much, you remember what you did, so you'll know what you're pretty close to what your grade is. Cancel that. Maybe a point. Okay, most 2. That'll be it. Okay, because if your because it affects your flow chart too, so probably a couple points each, so 4 points probably. That's what I did, I think, on the projects. Okay. So now, what did I say? In Evernote, we are ready for, after test 1, was there anyone that wants me to go over any of the problems in chapter 2 before we start into chapter 3? Is there anything that you had a problem with? Chapter 2, your problems were sequential logic, so there was not, we're still just in the sequential structure. And I believe your assignment was 5, is that correct? And I think that's the only problem. Then I gave you exercises 1 through 4, and the solutions to those should be in that solutions doc too. So you can go back and check yours and make sure you got the correct answers on exercise 1 through 4, although if you put it in there, I gave you credit. or I will give you credit for it. Number 5, do we need to do any of the others? 7, 8, and 9. Anybody have any trouble? Those were not assigned, just if you wanted extra practice. Taylor. Oh, the solutions are too, and that's how the PowerPoint was. Oh, goodness. Wonder how that happened, because last semester they never told me anything like that. Okay. All right. Let me go to see if I can find the correct solutions right now, and I'll post them. Should be, let me see if these are the correct ones. We'll pull them up. PDF solutions, PowerPoint solutions, 2 exercises. This was chapter 2. That says 3rd edition. But this should be, I think that's 4th edition, yeah. So how do I get 3rd edition in there? Okay, let's see. Let's look at these. View draft. Okay, so these aren't the ones that I put in there, huh? No? Explain why. Let's see. Let me open. Five, draw a flowchart pseudocode for an application. That's not the ones that I put in there? Because this has 8% sales tax on the item. Okay, let me, chapter 2 doc. See, when I put this one, let me save it as a PDF because it'll print the flowcharts if I don't. Save as PDF and solutions. Chapter 2, okay. Okay, now I should be able to put it in my where is that? Okay, this one you said is the wrong one. Okay, let me, oops. I'll take that. Delete it. And, oh, attach from, where's this one? Okay, let me sync it. It's syncing. It should give you the correct one now for chapter 2. Take a look at it, Taylor, and let me know before. I'm going to go ahead and go on, but let me know if that's the correct one. I also need to do that. Okay, so we're going to talk about making decisions. That's what chapter 3 is about. Making decisions. The first part we're going to look at is evaluating Boolean expressions. Who remembers what Boolean is? What is Boolean? True, false tables. That's a guy's name that came up with Boolean logic and or logic. We're going to talk about any kind of true false evaluations is a Boolean expression. And if you look on page 64, and let me see if I can go ahead and get this PowerPoint up, and hopefully if yours isn't the right one, I will open that right now and drag it over there. I think it was this class that noticed that it was not the correct ones, I think, maybe. There we go here. They're not the right ones. Okay, this one should start here with evaluating Boolean expressions. And the selection structure is what was introduced in chapter 2. But when a program's logic can take one of 2 paths that's based on a decision, it's also called an if-then-else structure. this is an example of driving directions, which we wouldn't even think of as programming logic. But everything we do that has decisions is the same as programming logic. If your driving directions say go north on 3rd Street, if 9th Avenue is closed for repairs, then continue to 10th Avenue and turn left. Else, turn left on 9th Avenue. And if, turn right on 6th Street. The end if is very important too. They didn't highlight it, but it is as important as the if, because in programming languages, if they don't know where the if ends, then this is included in the else portion if you don't put an end if in there, okay? So that's something that you have to remember, how whatever the language's syntax is for ending if, which in JavaScript it's a closing curly brace. But in pseudocode, you can simply say end if, okay? You have to have as many end ifs as you have ifs. So what I always did is on paper, I went and drew brackets to each if to end if to make sure that I didn't leave any off, okay? And I'll show you how to do that later. All right, so here's how you evaluate them. They are usually true-false evaluations. It's for a computer. The reason true-false works is because every circuitry has only 2 options. It's either on or off on that circuit. So that's why binary math is some of the most important things to know when you take logic, is that everything in the computer, even though we don't see it this way, is represented only by 1s and 0s. 0 means off, 1 means on, okay? So everything in your instructions to the computer, even though you don't see it, is all evaluated as on or off, yes or no, true or false, okay? But the computer in engineering, you would know that the electronic circuitry, every circuit only has, we used to say it's like a light switch. Every circuit is either flipped on or flipped off, okay? And I know I have some engineers. I know Seth is one. Okay, pseudocode. If Boolean expression, then perform action A, else perform action B, end if. This is showing you a template for the pseudocode and the flowchart for a selection statement or a decision. Every decision in a flowchart is marked by a diamond shape. So the decision is in the diamond, and the true side is always, the path is to the right, and the true side, I'm sorry, the false side is to the left. And here, the reason we have indentions, because it's easier to see that what you perform, if the Boolean expression is true, is indented. If it's not true, it'll go to the else, and it will perform this action and then end. So it only has 2 options, either true or false. Oops. So here's what we see. There are also, this is called a dual alternative because there is a process even if it's false or if it's true. This is called single alternative because if it's false, they don't want you to do anything. So that's just an if statement. And it'll have an if, end if, but it doesn't have an else side to it. So here's a business program using if-then. It's an overtime payroll program. So they have this many declarations. They have a string name, num hours worked, num rate, num gross pay. What's hours in week equals 40? What kind of a variable is that? Constant. Then num overtime rate is 1.5. It's another constant. So here, the declarations are in a process box. Then we have the input, so they're inputting 3 variables: the name, the hours worked, and the rate that they're paid. So then our decision is, are they overtime? Do they have any overtime? If hours worked is greater than hours in week, then we have to calculate overtime, right? If it's not greater than hours in week, then we simply say gross pay equals hours worked times rate. And then output the person's name and their gross pay. Okay? That's a very common, probably one of the first business programs that you'll write. Here's a program that uses stacked structures. What do you think it means by stacked structures? What's a structure? What are the three structures? Sequence, selection, and loops. Okay? Or repetition, sometimes the term used. So this particular one, what two structures do we know so far? What? Selection, sequence and selection. So what it's saying is this program is answered by structures stacked on top of structures, and it's only those two structures. So we start out here with what they've done is they've added a string to say yes or no, does the employee have participate in the dental plan? If the answer is yes, then they add a dental premium to their what they deduct. And here it asks, so the input, they've added one input, which is simply a Boolean expression. It can either be yes or no, true or false, whichever you want to ask them. Hours worked is greater than hours in the week. If it is, this part did not change, but they added another decision, right? So in this particular problem, what structure we have stacked? We have our input, then we have a selection stacked on top of another selection, right? Everybody see that? So in pseudocode, they show it here. Oops. And then they show it. Oh, what'd I do? Did I go too far? Oh, there it is. Yeah. So the second structure, you notice, is a single alternative. This structure is a dual alternative, right? There's both a yes and a no. But in dental plan participant, they only want to subtract the dental premium if the answer is yes. If the answer is no, then it just goes ahead and it outputs the gross pay. Questions? Everybody understand? Or don't know what to ask? Which? Everybody got it? Selection usually decisions are a little easier than loops, but you really need to understand decisions because you can't do loops in chapter 4 unless you understand decisions, okay? Because we have to make a decision before we repeat. All right, so decisions are the second building block. We learned sequence, and even though we have this one as to selection, you still have to understand sequence because sequentially we're still executing straight down. We're not doing anything but going one step after the other. But if this is true, we skip the else and go to the end if, right? We can't, if we look at the flow chart, if we go the yes side, we can't get to the no side once we go here, right? You see that in the flow? Right, see that? Okay, so using relational comparison operators. These are a little different. You remember this is called an equivalency operator, but it's really the assignment operator that we use. So in JavaScript, to use that as a comparison and say, does A equal to B, and use it as an equivalency, you have to use two equal signs. Because if you use one, it'll put what's in B into A, right? Remember what assignment is? When we say total equals 5 5 plus 4, it's going to put that total into that variable total. But if we put double equals, then it's going to compare what's on the left to what's on the right. Okay? And that's how these are: greater than, less than, greater than or equal to, less than or equal to, not equals. Not equals in JavaScript, exclamation point equals. And that means not equals. Okay? But you can look out at w3schools.com and it'll tell you all these operators. And Code Academy may tell you, I don't know. But reference in W3 Schools will tell you. You can usually both operands are the same type. That means that on either side of the comparison operator, they either need to both be data types or both be strings. You can't compare a string to a number. Okay? And that's what it means by they're the same type. Expression evaluates to either true or false. You can compare strings as well as numbers, but they have to both be strings. You can compare variables and constants. So here is an example of code in the two boxes that are equivalent. If customer age is greater than or equal to 65, then discount is equal to 10%. Else, discount's equal to 0, and if customer age is less than 65, then discount equals 0, else discount equals 10%, and if. So these are two ways to do the same comparison. And there's no one that's better than the other. It's just some people think more greater than or equal to. Some people automatically see it as less than 65. Okay? If customer age is less than 65, if it's greater than or equal to 65, because if I say less than 65, it's going to not include 65. Is that right? What does it say? If A is greater than or equal to B is true, then A is less than B is false. If A is greater than or equal to B is false, then A is less than B is true. Is that right? You're the math person, right? You said math, just not logic, just not programming, right? Yeah. So that's math. That's real math right there, right? Truth tables. Anybody not understand that statement? We can put values in there and it might make more sense. If say age is, let's try some values. If age is 32, is 32 greater than or equal to 65? Is that true or false? 32 greater than or equal to 65. False. So then A less than B is false if this is true, but it's not true. So that's not true. Double negatives, huh? Y'all thinking double negatives is kind of hard. If A, so here, if 32 is greater than or equal to B is false, which it is, then A is less than B is true, right? So this bottom statement is true if A is 32 and B is 65. Okay, what if A is 65? Which one of these is true? So what if customer age is 65? Then it'd be the top one, because A is equal to B, right? All right. So we just want to be sure that we can understand this manually before we put it in the computer. Then it makes more sense. Okay, so using not equal to in decisions, you're more prone to logical programming errors, and it's different in various languages. In other words, the way you code not equal to is different. If you can avoid it, it's better not to use not equal to, because that's considered a double negative. Sometimes there are specific problems that it's unavoidable, but if you can express it otherwise, then it's better not to use that. That's what it's telling you. Most programming languages support a not operator. It reverses the meaning of a Boolean expression. It's called a unary operator. It's used in front of a single expression. For example, age not 21, not age minus 21. You can't do that, but you can do this one.
You can do which one?
You can do the top one. If age is not 21. Okay, eliminate the double negative. Here's how we can do that. Positive equivalent is more clear. So if we say, if customer code is equal to 1, then you have a discount of 50%. If it's not, then have a discount of 25%. Instead of saying customer code not equal to 1, then you would only have one side, but it's easier to always use equal sign and have two paths than to do not equal. Okay? That doesn't mean it's wrong if you do that. It's just better. You will have less logic errors if you avoid that. Here's a common error, choosing the wrong operator. Using greater than when greater than or equal to is what is really desired. All cases of equal will be missed if this error is made. See, if you forget to put equals, like when we had customer age greater than or equal to 65, if you put just greater than 65, then anybody that was 65 would be missed, right? So that's why you have to be careful and make sure that you're not needing both. It's best to double check intended meaning with the person who requested the program. Phrases that can cause misunderstandings. No more than, at least, not under. It needs to be more specific than saying no more than. Do they want it to say greater than or equal to, or they just want greater than? You need to clarify that if you have a user asking you that. Okay, now we have compound conditions. These are a little tougher. Compound positions. We can use an and this is where the truth tables come in. An and decision is going to say that both of the selection statements or the decisions must be true for the logic to be true. Everybody remember the truth tables? And everything has to be true for it to be evaluated as true. It's also known as a nested selection or nested if. Nested decision contains a decision inside of another decision. Okay, so we're going to see these. Here's an example of an and. Here's a problem with a phone billing. Let me see if I can find this one in the book, what page that's on. Phone billing is over on page 79. I think that's just at 3. Oh, that's 3.7. Let me see. It's actually 76. Okay, the phone billing program, and actually on page 75 in your book is where you would watch the little video by the author on Boolean expressions and decisions if you're a little bit unclear. And logic, it says the basic monthly service bill is going to be $30. An additional $20 is billed to customers who make more than 100 calls and use more than 500 minutes. So the logic needed for this billing program includes an and decision, a decision in which more than one condition must be true for an action to take place. In this case, both a minimum number of calls must be made and a minimum number of minutes must be used before the customer is charged the additional amount. So what they've done in this flow chart or pseudocode, and if you can't, if you're too far back to see it, it's 3-7 on page 76 in your textbook, and it says we've made all these declarations here. Here's our input. We need the customer ID, the number of calls made, the number of call minutes, and then our customer bill, we're going to set equal to the constant basic service, because everybody's going to be charged $30, right? That's their basic bill. How many of you have never looked at your cell phone bill? Parents always paid it, you didn't look. Okay, this is how it's charged. I always look over it because a lot of times they mess up, right? Okay, so basic service is $30. If calls made are greater than calls, then you might say, oh, okay, I'm going to charge them the $20. No, there's two conditions have to be met. If calls made are greater than calls, which calls were 100, you see that's a constant, then if that's true, then we drop to the next if statement, and you'll notice that it's nested inside the outer if statement. That's why they call it a nested if. If calls made are greater than calls is not true, then it will immediately drop to the end if and only charge the basic premium, right? But if calls made are greater than calls, and if call minutes are greater than minutes, right, then it will charge customer bill equals customer bill plus premium. But if calls made are greater than calls, it'll still test this one. But if this one's false, then it's going to go to this end if and then to this end if, right? So both of them have to be true. This is very important logic to understand. Do you see how it works? Some people can see it better in the flow chart. The flow chart says, here's my first decision. I've already charged everybody $30, but if calls made, say calls made are 75, what's going to happen? I'm going to go no, and it goes all the way around that nested if and down to my output, right? Okay, what if calls made are 100 and call minutes are 75? Nothing, because it'll go to the yes here, but then it'll drop to this no side all the way down to output, right? Okay, anybody have any questions? That doesn't make any sense to you? Come on, tell me if it doesn't. There's probably somebody else. Okay, efficiency. This is something that nesting and decisions for efficiency. If we know, sometimes we don't know this, but if we know that the majority are going to have 100 minutes or 500 minutes or more, but they're never going to have the calls as often, over 100, then we would switch those nested ifs. We want whichever one is going to get them every time, or the majority of the time, to be at top, so it doesn't have to always test the second if. Right? Does that make sense? So you want to choose the right decision to put first, and it can improve the program performance. So it can improve the speed of the program. The least decisions that the computer has to make, the faster the process is. Okay? Does that make sense? Okay. So next we go using the and, oh, is that where I was at? Conditional and operator and, okay. The and operator you use is 2 ampersands, and we should be going through that here in a second. Okay, here's the truth table, and this is what we learned in mathematics, and we have something called a shortcut evaluation. Here, if x, this is the one for and, if x and y are true, if x is true and y is true, then x and y is true. But if x is true, y is false, then x and y are false. If x is false, y is true, x and y are false. If x is false, y is false, then they're both false. So there's only one way to get a true on an x and y. They have to both be true. So a short circuit evaluation evaluates each expression using an AND operator. It evaluates only as far as necessary. So if we're evaluating X and X is false, then we don't have to evaluate Y, right? Because in an AND, if it's an AND, if X is false, then we're done. That makes sense? Okay, so that's called short circuit, because with an AND, it doesn't matter. If X is false, then we don't have to evaluate Y. Now, if X is true, then we also have to evaluate Y in order to know if it's true or false. So here's one where the computer executes both flowcharts in figure 3-9 in the same manner. The computer makes decisions one at a time in the order they are given. In an AND expression, if the first test is false, then the entire expression is false and the second test is not performed. So what it's telling you is if you use the if with an AND, then it's shorter, because if the first one is false, then it's going to drop out. So this one is a nested if, and it's going to have to do both, even if this one's false. Oh, wait, no, these are both. Yeah, this is the nested if. So this one, you can't short circuit. This is the AND. You see, you only have to have one decision if you use the AND, because both X and Y are in the one decision box. If you use a nested if, you've got two decisions. You put the first X here and the Y here. Okay? So that's what it's showing you there. It's with an AND expression.
You can use either one of them?
Yes. You can use either one, but the more efficient way is with the AND. But if the AND doesn't make sense to you, you can do this until this makes sense to you if you don't understand the AND logic. Okay, avoiding common errors in an AND selection. Common errors when making AND selections. When AND selections are nested incorrectly, then you perform an action when only one condition is satisfied. Performing an action twice that should only occur once. Failing to include a complete Boolean expression on both sides of the operator. Those are some of the common errors. Let's see, we're not going to get through this. The next logic is the OR logic. And that one, let me go to the truth table because it's really easier than the AND. In the OR logic, if the first question is true, then the logic does not proceed to the second question, because if the first is true, then X or Y is true. So you have more opportunity for true with X or Y, right? It's just like on our checking accounts. If we say my husband's name and my name, then usually they require both signatures on a check. If you say or, it can be either one. Okay? So that's the difference in the and the or. And there's the common errors, avoiding common errors, example of using and or. So you need to go through these, and I'll make sure. Let's see, what's that one? We will go through some problems next time. So be sure you've read this, and if you have any questions on and or on the if, we'll go over those next time, and we'll work some chapter 3 problems.
Professor?
Yes.
Just wondering if I can check something with you.
Okay, just a second. Let me see if I can get this to stop. It's not wanting to stop the broadcast now.